Air and wind. We are about to discuss something that is around us all the time. We notice it when the leaves of the trees rustle, or the pages of an open book begin fluttering when the fan is switched on. Air. Air is something that we cannot see, but we feel its presence in so many ways. It is hard to believe that this transparent form of nature is a mixture of many other gases. Let us see what the various components of air are. One of the most important components of air is water vapor. As we know, when air comes in contact with a cool surface, it condenses and drops of water appear on the cooler surfaces. The presence of water vapor in air is very important for the water cycle in nature. Another crucial component of air, because of which all living organisms survive, is oxygen. The proof of this fact is the burning candle that goes off when an inverted glass is kept on it. This happens in the absence of oxygen, which it needs in order to burn. You must have noticed in the previous experiment that a major part of air is still present in the glass even after the candle blew out. This indicates the presence of some component in the air which does not support burning. This part or component of air is called nitrogen. Animals consume oxygen for respiration and produce carbon dioxide, which forms a small component of air. Plant and animal matter also consume oxygen and produce carbon dioxide and some other gases on burning. You must have seen smoke being emitted from the burning of fuel. Smoke contains a few gases and fine dust particles and is often harmful. Thus, dust particles are always present in air. There can be variations in the composition of air from place to place. In general, we observe that oxygen and nitrogen together make up 99% of the air. The remaining 1% is comprised of carbon dioxide and a few other gases, water vapor, and dust particles. If water is heated in a vessel, you will notice little bubbles on the inner surface of the vessel right before the water starts to boil. These bubbles come from the air that is dissolved in the water. As we continue heating, water itself turns into vapor and finally begins to boil. The presence of air is felt in case of soil as well. When water is poured on a lump of soil, it displaces the air in the form of bubbles. The organisms that live inside the soil, as well as plant roots, respire in this air. A lot of burrows and holes are formed in deep soil by the animals living in the soil. These burrows also make spaces available for air to move in and out of the soil. However, when it rains heavily, water fills up all the spaces occupied by the air in the soil. In this situation, organisms living in the soil have to come out for respiration. For instance, earthworms come out of the soil only during heavy rains. Moving air is known as wind. Such air exerts some kind of pressure. We all have seen the tricolour flying in the air numerous times. It is the pressure that air exerts that makes the flag flutter continuously. Another phenomenon with respect to air is a continuously moving large mass of air, which is known as wind current. Wind currents are generated because of the uneven heating between the equator and the poles. Regions close to the equator get maximum heat from the sun. The air in these regions becomes warm and rises, while the cooler air from the other side of the equator moves in. These winds blow from the north as well as from the south towards the equator. At the poles, the air is a lot cooler than at the latitudes. The warm air at these latitudes rises up, and the cold wind from the polar regions rushes in to take its place. In summer near the equator, the land warms up faster, and most of the time the temperature of the land is higher than that of the water in the oceans. Thus, there is an imbalance in heating. The air over the land gets heated and rises. This causes the winds to flow from the oceans towards the land. These are called monsoon winds. In winter, the wind flows from the land to the ocean. The monsoon winds carry water and bring rain. Air is a gift of nature. But sometimes it does not take time for it to turn into a curse. There are certain situations that can sometimes create disasters and pose a threat to human, animal, and plant life. One such situation is a thunderstorm. A typical thunderstorm cloud develops when warm air rises from the surface of the earth. As the warm air rises, it cools and water vapor condenses into minute cloud droplets. In a thunderstorm, the updraft of warm air is rapid and the cloud builds up quickly. When the thundercloud grows to maturity, water and ice droplets come together and precipitation begins. The onset of a thunderstorm always includes strong gusts of wind, heavy rains, and lightning. Clusters of thunderstorms accelerate the speed at which a column of rising air is generated in a low-pressure zone. Pushed by the winds, the disturbance becomes a mass of thunderclouds that grows as warm and moist air seeps into the low-pressure void, thereby creating a cyclone. The central area of lowest pressure is called the eye of the cyclone. Surrounding the eye is the eye wall, which is a cylindrical band of high-speed winds. Air at the sea surface gets sucked towards the eye and thrust upwards in the eye wall, forming rain bands on its trip inwards. As the air rises, the moist air cools, causing water to condense as fine mist or ice while releasing a huge amount of heat. In meteorology, a cyclone is an area of closed circular fluid motion rotating in the same direction as the Earth. This is usually characterized by inward spiraling winds that rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere of the Earth. Most large-scale cyclonic circulations are centered on areas of low atmospheric pressure. Cyclones, which are also known as hurricanes, have caused large-scale damage in the past. In 2005, Hurricane Katrina, the costliest natural disaster and one of the 5 deadliest hurricanes in the history of the United States of America, went on to take at least 1,836 lives, doing some serious damage to property in the process. The speed of the winds was estimated to be at least 280 kilometers an hour. The total damage stood at a staggering $81 billion. A mesocyclone is a vortex of air approximately 2 to 10 miles in diameter within a convective storm. It means that it is air that rises and rotates around a vertical axis, usually in the same direction as low-pressure systems in a given hemisphere. Such cyclones are not unique to Earth. Cyclonic storms are common on Jovian planets, as in large planets that are not primarily composed of rock or other solid matter. The examples of such planets are Jupiter, Saturn, Uranus and Neptune. The small dark spot is an example of such a cyclonic storm on Neptune. Another devastating form of air and wind is a tornado. As warm moist air flows into a storm, it gets pushed up and twisted by the upper level winds. As this rotating column of air gathers force, conditions are right for a collision below. When rain-cooled downdrafts hit warm air near the ground, a low-hanging revolving cloud forms beneath, resulting in a tornado. A tornado is a violent, dangerous rotating column of air that is in contact with both the surface of the Earth and a cumulonimbus cloud, or, in rare cases, the base of a cumulus cloud. It is a dark funnel-shaped cloud that reaches from the sky to the ground. Most tornadoes have wind speeds less than 110 miles per hour, or 177 kilometers per hour. But the most extreme ones can attain wind speeds of more than 300 miles per hour, or 480 kilometers per hour. Tornadoes come in many shapes and sizes, but are typically in the form of a visible condensation funnel whose narrow end touches the earth and is often encircled by a cloud of debris and dust. Tornadoes have been observed on every continent except Antarctica. However, the vast majority of tornadoes in the world occur in the Tornado Alley region of the United States, although they can occur nearly anywhere in North America. As we have seen, air and wind have their own ways of making their presence felt, sometimes for the better, sometimes for the worse. Air helps us survive, but if the winds show their fury, it can cause massive destruction.